tonight's lesson is on equivalent ratios. First of all, a ratio is just a comparison of two numbers. There's three ways to write a ratio. You can use a colon, you can use words, or you can use a fraction. In this example, we have 3 red tiles for every 4 blue tiles. So the ratio is 3 to 4. We could do 3:4, 3/4, or 3/4 in fraction form. And when you'd use something like this, if you were creating a tiled tabletop and maybe creating a beautiful mosaic, you put down 3 red tiles, then 4 blue. 3 more red tiles, 4 more blue. And so the ratio of red to blue would be 3 to 4. I want to talk about equivalent ratios. I want to look at these pies and how we've cut them up. We cut this pie in half, we cut this pie into fourths, and we cut this pie into eighths. If two ratios have the same value when simplified, they're called equivalent ratios. For example, if you take a pie and you cut it into 2 pieces, and you say to yourself, you know what, I'm not all that hungry. I think I'll just eat 1 out of these 2 pieces. So here's the piece you ate. You ate 1 out of those 2 pieces. Well, I'm going to tell you, if you eat 1 out of those 2 pieces of pie, if you only cut it into 2 pieces, you have eaten half the pie. Let's say you have the same pie, but this time you cut it into 4 pieces, and you're like, I'm pretty hungry. I think I'll eat 1, 2 of those 4 pieces. Well, if you eat 2 out of those 4 pieces, you have still eaten half the pie. Finally, if you cut that pie into 8 pieces, and this time you're like, I'm really hungry. I think I'm going to eat 4 out of those 8 pieces. 1, 2, 3, 4. You eat 4 out of those 8 pieces of pie. Believe it or not, if you eat 4 out of those 8 pieces of pie, you still have consumed half the pie. And because 1 to 2 is 1/2 as a fraction, 2 to 4, 2 out of 4 becomes 1/2 when we simplify it. 4 to 8 becomes 1/2 when we simplify it. That means 1 to 2, 2 to 4, and 4 to 8 are all equivalent ratios. No matter how you cut it, you're still eating half the pie. Let's take a look at a paint mixing example. Mrs. Yankowski and Mrs. Van Dyke need some dark green paint to create a poster for Mrs. Yankowski's classroom. The only problem is that they only have blue and yellow paint, and they need green. They know they want dark green paint, so they decide to mix 3 tablespoons of blue paint with 1 tablespoon of yellow. They're going to mix 3 blue with 1 yellow. That's going to give them a beautiful dark green. They've got more blue, so it's going to be a little bit darker green. So there's our 3 blue to 1 yellow. And all I want you to do is write the following ratio in 3 forms, using a colon, using words, and in fraction form. So I want you to take 3 tablespoons of blue paint for every 1 tablespoon of yellow, and just write the ratio in 3 forms. I'm going to ask that you go ahead and pause the video, try it out, come on back. All right, hopefully you paused the video. Well, if you see we have 3 blue to 1 yellow, you can use a colon, 3 to 1. You could use words, 3 to 1, or you could use a fraction bar, 3/1. The only thing you shouldn't have done is you should have never put that 1 first, okay? It says blue and then 1 tablespoon of yellow. 3 tablespoons of blue for every 1 tablespoon of yellow. So blue comes first. So if you did 1:3, or in any case you put the 1 first, that's not okay. Next example, let's talk about equivalent ratios. Write 3 ratios that are equivalent to the one given. 6 tablespoons of blue paint for every 2 tablespoons of yellow paint. So I have 6 tablespoons of blue, 2 tablespoons of yellow. I need you to come up with 3 different equivalent ratios for 6 blue to 2 yellow. Take a minute, pause the video, come on back, we'll try it together. Okay, hopefully you can see you have 6 blue, 2 yellow. If I want, I can break this down. Instead of saying 6 blue, 2 yellow, I could get the exact same shade of green, just a smaller amount if I only did 3 blue to 1 yellow. 6 to 2 is the same as 3 to 1. And I can do that by 2 divided by 2 is 1. 6 divided by 2 is 3. So 6 to 2 and 3 to 1 represent the exact same ratio. You're going to be able to create the exact same shade of green. Let's try another. So this time again, hopefully you came up with another one. We start with our 6 to 2. But this time I'm going to go ahead and say I have 6 to 2. Let's say I put in 6 more blue, 2 more yellow. Still the same shade of green. It's still going to be an equivalent shade of green. You're just going to have more of it. So let's take a look. So now, instead of 6 to 2, if I look at how much blue I have, well, 6 to 2, and then I put in 6 more blue, 2 more yellow, I now have 12 blue to 4 yellow, and I've still created the exact same shade of green paint. Well, I could work this way. 2 times 2 is 4, 6 times 2 is 12, and 12 to 4 is completely equivalent to 6 to 2. They're going to make the exact same shade of green. Let's try another one. Here's our third ratio. Now instead of doing 6 to 2, 6 to 2, I'm going to do 6 to 2, 6 to 2, 6 to 2. I'm going to start out with my ratio of 6 to 2, and I'm going to decide I want 3 times as much green paint. So I'm going to put in my first 6 to 2, my next 6 blue, 2 yellow, and a third 6 blue, 2 yellow. I've made the exact same shade of green. I just have 3 times as much. So 6, 12, I actually put in 18 blue and 2, 4, 6 yellow to create the exact same shade of green, but it's just 3 times as much. 2 times 3 is 6, 6 times 3 is 18. So 6 to 2 is the exact same ratio as 3 to 1, exact same ratio as 12 to 4, and the exact same ratio as 18 to 6. Those are all equivalent. They're going to produce the exact same shade of green paint. Let's take a look at another example. Mrs. Yankowski has 16 homework papers and 14 exit tickets to return. Mrs. Van Dyke has 64 homework papers and 60 exit tickets to return. For each teacher, write a ratio to represent the number of homework papers to the number of exit tickets they have to return. Are the ratios equivalent? Explain. So what I need for you to do is pause the video, try it out, come on back, and we'll complete it together. As I look at this example, I think to myself, okay, I want to write a ratio that represents the number of homework papers to the number of exit tickets. Then I want to know if they're equivalent. So first of all, I'm going to do homework papers to exit tickets. And for Mrs. Yankowski, she has 16 homework papers to hand back and 14 exit tickets. So we're going to do 16 to 14. Maybe Mrs. Yankowski is only handing back in one of her classes. Mrs. Van Dyke, on the other hand, has several more to hand back. If she hands back homework papers to exit tickets, she hands back 64 homework papers to 60 exit tickets. And I say to myself, she's definitely handing back in more classes than Mrs. Yankowski. Now, if I want to see if these are equivalent ratios, I would need to write them with the same denominator and then compare. So what I want to look at here is I say, you know what? It looks like Mrs. Van Dyke maybe handed back in 4 more classes than Mrs. Yankowski. I look from 16 to 64. I say that's probably about times 4. So what I personally would do is I would take a look at Mrs. Van Dyke's and I would say I'm going to try to divide top and bottom by 4 so I can figure out how many papers Mrs. Van Dyke handed back just in one class. So if we, on our calculators, do 64 divided by 4, we come up with 16. Ooh, they both, per class, handed back about 16 homework papers. Let's hope our denominator comes up to be 14. If it does, then they're totally equivalent. So let's do 60 divided by 4. Oh no, that's 15. So that's a problem. These actually are not equivalent. 16 to 14 certainly does not equal 16 to 15. Those ratios are not equivalent because when I tried to simplify the 64 over 60, it simplified to 16 over 15, not 16 over 14. So those are not equivalent ratios. The last item I'd like you to take care of is I'd like you to answer, do a nice write-up for this focus question. Be ready to come on into class tomorrow and share it. What does it mean if two different ratios describe the same situation? Like in this case, we talked about 6 to 2 describing the same situation as 3 to 1 when we were creating that beautiful green paint. How can being able to describe situations in multiple ways help you solve a problem? So go ahead and try to write those up tonight. Be ready to share them tomorrow in class. Thanks. Have a good night.